Okay, crazies, let's try this again. Hey, what's up? How are you? Woo, I'm awesome. All right, Carlos, did that do the trick? Carlos, did that do the trick? Yo, yo, yo.
I can hear you. I can hear you. Perfect.
Okay, good. Awesome. That's good. Good. You know what that's a quote from?
What was that?
When I say good, do you know what that's a quote from?
Oh no, I don't. I don't.
Really? Star
Where's that
Wars,
from?
dude. Star Wars.
Star Wars? I've watched it when I was little, but recently I haven't watched it at all.
Well, it's one of the old ones.
Is it
I'll say
that that big monster that's green? I think from where they're rescuing Princess Leia or something.
No.
No.
No. It's the Emperor when he's talking to Anakin, and Anakin switches to the dark side. Anakin says, "I will do whatever you ask," and I say, he goes,
Oh, okay.
"Ooh."
Okay, yeah, I know.
That's it.
Right.
That's it.
Yeah.
All right. I don't know why it wasn't working prior to this, but hopefully now everything's fine, and it will work.
Yeah, I
Let's
don't know
just
why
let
it wasn't
Brandon-
working.
Yeah, I don't either. We'll let Brandon come in. They're probably, it's office hours don't officially start till 3:15 anyway. So there may be a few minutes and there'll be a few other kids. So we'll just hang out for 3 minutes.
All right, sounds good.
Are you in a meeting?
About to be. What's up?
Nothing, don't worry about it. Ooh, see in the sky. Hey, Carlos, why don't you come to school in person? I'm curious.
I've recently gotten corona. I was planning on going to school in person, but
Oh my God, you yourself were tested positive?
well, I didn't test out. My parents didn't allow me. I don't know why, but I lost my 2 senses, so which is one of the reasons why I knew I had corona.
You lost 2 of your senses? What was that?
A lot. It was smell and taste. Smell and taste.
Oh, but you never took a test?
I never took a test. I
Yeah,
haven't.
but you were probably positive.
Yeah. One of the reasons why.
Where do you think you picked it up?
What was that?
Where do you think you picked it up?
I actually don't know. I don't know. I'm curious as well.
Do you go out and just live your life as normal?
Well, not really. Just the only times I went like outside out of my house was whenever I got some groceries or something.
Oh, really? That's it?
Yeah, that's it. Nothing major.
I'm sorry y'all have to live like that as kids. It's tough to do that as kids. We'll wait one more minute and then we'll get started. Surely more than 3 people will show up. Actually, only 2 people. 2 people and a dog have shown up.
Hey, have you gotten corona or no?
Nope.
Not at all. Oh,
I'm pretty careful about stuff. I still go out and do things, but most of the activities that I partake in are not group activities. Like I fish, I hunt, I look for reptiles and amphibians called herping.
Okay, so you're
Um,
very careful. Yeah.
Yeah,
Okay.
well, I mean, I'm just, the things that I do in my free time are not big group activities. The only thing that I do that are big group activities, I go to a lot of musical concerts. I'll go to a lot of musical concerts.
Oh, really?
Yeah, I probably go to, I don't know, half a dozen a year, 6 each year. And I have not been, they haven't even been
Hey,
having
Mr.
concerts.
Pope, sorry to
Yeah.
interrupt you, but my dad actually just told me right now that we're gonna be going somewhere pretty soon. If
Mhm.
if he calls me in before we're able to retake, is there any way I'd be able to reschedule for maybe later today so I could retake the test? And
I tell you what, I'll record it. And I'll post it. Let me make sure I'm recording.
all right, thank you, sir.
And I'll post it. Yep, I'm recording. And I'm gonna go ahead and start. So it is 3:16 now. So there's only, it looks like 6 of you guys.
Yeah,
And I'll go
Thanks,
ahead
sir.
and begin. You're welcome. All right, so the very first question. This was the question that was missed the most out of every question on the quiz. Number one was missed the most. And this is the one that I was telling you guys, you have to look at the pattern. The thing that might throw you off a little bit is that when you're looking at it, it's not two double hets. And I think that might have been something that threw people off. But I have a heterozygous, in this case, it doesn't even say if it's male or female. It just says this is one parent and they're heterozygous for these two traits. And then I have another parent that's homozygous for these two traits. Now, I know what is going to be dominant. I know in this case that gray and normal are dominant traits. So what would you guys, how do you think I know that gray and normal wings are dominant? How do I know that?
Because heterozygous are always dominant.
Yeah, exactly. So they're always going to express the dominant allele, period. So there's a couple of things that you could have said. There were two ways to get points. One, oh shoot. One, is this a linked trait or is this an unlinked trait? What do you guys think? Given the ratios.
Linked,
Okay, why do you say that?
because it's in half of the things, half of the
What?
offspring.
Okay, what alleles do you think are, well, okay, what color or do you think normal wings is most likely linked to?
Gray.
Yeah, I mean, you can see it. So in this case, it's almost round up to the nearest hundreds in this point. Like, right, we're dealing with thousands of individual or more than 1,000 individual, 2,000 individuals. So I've got, yeah, well over 2,000 individuals. So we'll just round to the nearest 100. So basically 1,000 that are gray and normal and 1,000 that are black and vestigial. Those genes are definitely linked. So if I were going to say what type of inheritance is here, I would have gone one. I don't see any blending between black and gray, right? There's no blending here. I would have just said simple dominance. Simple dominance. I cannot see now. Dominance. Or I would have also said these are linked genes. Linked genes. That's it. That's all you would have had to say. Either one of these things would have given you points. Either one of them. They're definitely not going to be unlinked. If they were unlinked, you would have a distribution that wouldn't be near this extreme. Now, you could come over here and do a Punnett square. In this case, a dihybrid Punnett square. But do you really want to spend time doing that? You don't. I would just look at these ratios and go, wow, gray and normal wings are almost always together, black and vestigial wings. Literally, in this case, I guess looks like it is 500% more common to see them in the not linked when you look over, when you compare these two. There's just that big of a difference between them. If this would be 5 and this would be 5-to-1 ratio, that's just, there's no way. These are going to be linked genes all day long. And there's no blendings, there's no codominance, there's no incomplete dominance. It's just simple dominance or recessive. Okay, questions about that?
So when it says state the type of inheritance, that means just if it's linked or not.
Yeah, well, let's look. Let me change screens real quick. Let me see if oh, no, I haven't got that. Let me change screens. Let's look. Types of genetic. Whoa. Classic. Okay, here we go. There are 5 basic modes of inheritance. So we got single gene, autosomal dominant, autosomal recessive. So we were looking at autosomal dominant, and I'll bring up another image to explain what autosomal versus sex-linked is again. We got sex-linked traits if they were, but we know that wasn't sex-linked because it didn't give us whether it was male or female. If we saw it was predominantly male, then we would say it was an X-linked or sex-linked trait. But we don't know that. So really, I'm just looking at, is it a linked trait or not? Is it a, let's see what else. They give us X-linked, autosomal dominant. There's still more than that. Let's see. Single gene, inheritance, facial, mental genetics pattern. Maybe what I'll do is rather go back to our quiz and I'll put out a little definition next to each one of these. This is it, right? Here we go. So simple dominance means dominance always expressed. Simple recessive means the same thing. Simple recessive, if I were to put that there, the recessive is only expressed paired, another recessive allele. Did I put 3 S's? Okay, and then linked genes which are found on the same chromosome, especially same loci on the chromosome. And then X-linked, also known as sex-linked. X-linked and sex-linked are the same thing. Sex. Because they're linked to the X chromosome, the X chromosome. So this would be patterns where the gene is and expressed primarily. Those are the big 4 that you really need to know. And really, these 2 are one and the same. But when you're looking at this, or you could actually put unlinked too, unlinked genes. Unlinked genes. In this case, alleles sort independently sort. And I'm going to put FOIL. Remember when we use FOIL, how we can separate those alleles and then none of them have to be linked to one another when you're using the FOIL method. So alleles independently, in this case, FOIL sort due to the being found. Separate. But you're just looking for that pattern. Anytime you see them disproportionately linked, like these two colors, gray and normal rings, black and vestigial rings, these things are linked. Something's going on. These genes are found on the same chromosome. They're being linked together. They're very seldomly are they independently sorted. Very seldomly are they independently sorted. Okie doke. Questions, comments? Yep, there is. Oh my goodness. Okay, thank you, Carlos. Deuces. Let's go to the next one. Oh my gosh, this one, a lot of people got this one, but I was, yeah, well, you had to think about this. I like this question. So let's preview it. Let's work it. I'm going to annotate this too. So give me an annotate function here. I was about to smoke somebody in class for jacking with the screen today. Okay, let's see. Creeper in chickens is a condition in which the chickens are born with very short legs. The creeper allele is dominant over the normal allele. Embryos, which are homozygous for the dominant allele, fail to develop. So if you are, there's different genotypes, right? Creeper's dominant. So let's put that here. Creeper is dominant. Lowercase is recessive. So if you have this allele, you have creeper. But it also tells us some more information that if you're homozygous dominant, that you are going to do what? What happens if you're homozygous dominant?
You're gonna die.
You're gonna die. If you're homozygous dominant, you're a dead chicken. No good. Poor chicken. See his little chicken beak? Dead chicken. Okay, so if this is this chicken here, these are not going to be found, right? These chickens are dead. Okay. And it says that we're fail to develop into viable chickens. So they never are born. I mean, they don't even hatch, right? It's just an egg that you can eat and that's it. What phenotype or phenotypic ratio would you expect in the live offspring when you cross two creeper chickens? Okay, so creeper chickens that are living are going to be what? What is it going? Their genotype going to be? If you express creeper and you're living, what's your genotype going to be?
Wouldn't it be capital C, lowercase c?
Yeah, what do we call that?
Heterozygous.
Yeah, you're going to be a heterozygous creeper. All right. Some of you guys are creepers. All right. I'll tell you a funny story if you can remind me at the end of this. All right, about creepers. Excellent. Which of these four are dead? Let me ask one of you guys, which of these four are dead? Osamba, see if he's still here. He is not. His daddy had to call him somewhere. Okay, so in this case, Carlos, which of these four are dead?
The first one in the first row.
See, this one is dead, dead, dead. So it's gone. So in this case, now we have to just put a ratio together over here. So I've got this that occurs twice, once, twice, 3 times a lady. There we go. There's 2 tally marks here and here. So I'm going to put a little check mark. I like to use check marks to keep everything organized. I've got 1 here. So homozygous recessive occurs once. So I've got a ratio of a 2 to 1 ratio. So I'm going to come over here and look. And these are creepers here. So I've got 2 creepers, 1 normal. There we go. Ta-da. Ding dong. You got it. All right. I'm gonna give you guys 60 seconds. Somebody walked up. I'm gonna talk to them. I'm gonna mute myself, and you guys think about any questions you want to ask me about this while I talk to this person. Okay, sorry, I'm back. So what, you guys put some questions in here? Man, what the heck? Daniela, could you tell me what the, I knew this question, but it was.
It's because I read
PPL.
I read homozygous dominant for creeper chicken, so I thought it was 2 capital C's by 2 capital C's, and I put all creeper.
Oh. Yeah, creeper chickens are chickens that express creeper but are living. In this case, I thought it was kind of a tricky question, but I think it was kind of, it was still fair. They're really trying to check your reading skills here. You know that these are dead if they're this genotype. And so if you're going to be living, to mate, because you're crossing these two, right? You're going to cross 2 creepers. And if you're alive, you can't be this. But yeah, you're heterozygous. Yeah, you see it now. Could you please tell me what PPL means? I don't understand you guys shorthand.
People.
What's PPL? Oh, people. You were thinking that this is people and not, okay, not chickens. What about SMH? What's that?
Shaking
Shaking my head.
Shaking my head. Okay. Well, you could say shaking my head. All right. Let's move on with our lives. LOL. Thank you. I get that. I get that one. Done. We're going to clear my drawing, my annotations. They are clear, all drawings. Out. Done. All right. This one. The children in the family have blood groups A, B, and O. What are the genotypes of their parents? Well, this is where you're just going to have to do some crosses. I think I actually did this one in class with you guys. Most people got this one correct, but I will go ahead and do it anyway, in case one of you guys didn't get it. So I know that I get all 3 of these phenotypes, not genotypes, but phenotypes. I know these phenotypes come out of these parents. So what combination could I use to get this? These are my combination, my possibilities. So let's just deal with the first one here. Got an IV. I have somebody that's AV blood. They're a good Lord. AB, and then they are IOO, which is O. So here I've got an A-type person. Here I have another A-type person. And here I've got a B-type. Lord, I have become Mr. Leniger in the virtual environment. Does this work? Yes, no, maybe so.
Yes.
It does work? I don't know. Let's look.
No.
This
Okay,
is
then it doesn't
A.
work.
Yeah, this is A. This is only B. Remember, there's different, so let's do the phenotypes. Maybe we should do that. I've got A type. A can be expressed as homozygous dominant. Or it can be expressed as heterozygous. That is possible. Or you can have AB. AB is only going to have one possibility. I say or. Shouldn't have said or. That doesn't make any sense. Or I need a lobotomy. That's supposed to be an I. There should be the same size, but oh well. Okay, then I go to B. B type blood. B type is going to be homozygous dominant. It's really homozygous, is all I need to say. Homozygous. Or you can be heterozygous as well and have the O allele. Or you can be O type, and O type, there's only one possible genotype, and that's two small i's. So this does not work. Poo-poo on this. Let's try another one. What do you guys think works? What two genotypes should I use? Of these three remaining, which should I use? What are you guys thinking? What should I use?
The second one.
The second one? Okay, well, let's just see. I've got A. Good Lord, that's terrible. Let me get an eraser. I can't take it. It reminds me too much of Mr. Leniger. Okay, let's do it again. Try to be a little more careful. A. A, B, and then I'm going to have B. That's supposed to be a B. I, A, I, and I, O, and O. So I've got an O type here. I've got a B type here. I've got an A type here. I'm cooking with Crisco. 'Tis the correct answer. Move on with my life. Most people got this one right too. You didn't. But that's a co-dominant situation. That one worked. So, questions before I clear the drawings? Good oak. We're off to see the wizard. Okie dokie finokis. Let's, before we look at this again, this question, let's go back to karyotype. Second. Karyotype. All right, so I'm going to look at a karyotype. Let's look at this biggie right here. It's nice. This is human. I know this is going to be human because I have 23 pairs of chromosomes. Remember, our chromosome number, our diploid number is 46. also know that this is a male. So let me annotate this again. I know this is a male because I have an X and a Y. I have one very long chromosome and I have one very short chromosome. These are my sex. And I'm going to put an X for sex. These are my X chromosomes. I'll put a little CH for chromosomes. These are my X chromosomes. Question becomes, what do we call all of these? Okay, when we studied mitosis and we did our mitosis versus meiosis diagram, or not, it was kind of a diagram, the Pictionary game. The fifth one said cell type. We had two cell types. We had gametes, and what was the other cell? The cell type that your whole body was made of. What did we call those types of cells? What did we call those types of cells? The ones that your body is made of. Your body is made of what type of cell? There's two categories. Gametes and something else.
Does it start with an S?
It does start with S. It's right. I need to know. What do I put here? It does start with S.
Is it like something soma?
It does. A somatic cell. So these chromosomes are known as my autosomes because they have everything to do with my body and they have nothing to do with my sex. Every male and female have the same 22 chromosomes. Now they're gonna have different alleles for these genes, so they may express different traits, but like my hair color is going to be found on one of these chromosomes. And I don't know which chromosome carries hair color. It doesn't make any difference, but it's not on my X chromosomes. These have to do whether you're born a male or a female. Females are going to have 2 X chromosomes, but they'll have the same autosomes. Let's just see if that's true. Let me clear these drawings. And let's go to the next image. Let's see. This is a dude too. Let me see if I can find a female. Oh, here's a female. Ta-da. So there's no Y chromosome. They have 2 X chromosomes. This is a femalian. Oh, except they got 3 right here. They got 3 here. That's not true for most females. If you have 3 on this chromosome, I think that gives you, I think it's Klinefelter's disease. I can't remember what 7 does. This is a genetic abnormality. Let's go for another. That's a Down syndrome. I don't know any of you guys. That's the 21st chromosome. Let's go to this one. Here we go. This is better. This is nice. Let me click on this. Bring this up. This is a better image because it shows both. So we're looking at a male or female here, right? So all of these chromosomes are the same until you get down at the 23rd pair, and you'll see these are 2 X's. And here for dudes, we have an X and a Y. Same here. I'll pull that image up, make it bigger. There you go. Female, male, but everything else is the same. These are our autosomes. These are our sex chromosomes. So let's go back to our question. Maybe I can get back to our question. I don't know. Look at Earl crying. Why do you have a crying person, Earl?
Because I always fuck my quizzes.
Oh, really? That's why you keep the crying person there? Okay. So it says, the karyogram, also known as a karyotype, is shown of an African marsh rat. We know it's not human because look, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so they're 21. So they hit their diploid number is 42, and ours is 46. Different number of chromosomes. Females are XX and males are XY. So State with a reason. So let's see, what would be my reason? And most people got this one. It was either you knew it or you didn't know it. So what would be my reason here? Is this male or female? Let's see.
It's a male.
It's a male. Oh, okay. You guys can see this, yes?
Yeah,
You can or not?
we can.
Okay, okay. So male because done. DONE. I'm feeling good about it. And that would have scored you a mark. That would have scored you a mark. Which leads us to this question. I thought this question was beautiful. This was on the final exam for my students last year. So this was from 2018 test. The image shows chromosomes from 4 cells of an insect at the end of meiosis. So it's at the end of meiosis. What type of cells does meiosis produce? What kind of cells does meiosis produce?
Wait.
Gametes.
Okay, it produces gametes. That's nice. Are gametes haploid or are they diploid?
Diploid.
Okay, so let's go with Earl's. Let's go with Earl's take. Let's just follow Earl's logic for a second. Earl, are you diploid?
Maybe.
I need to know. Are you diploid? Yeah or nay?
No.
You're not.
Wait,
So
yeah,
you don't have.
yeah, I am.
Okay, and so you say you're diploid, and then you're going to go through 2 rounds of division and produce more diploid cells at the end of meiosis. So let's do this. Oh, go back to drawing again. Let me finish this. So your sperm, because that I'm producing gametes again. And I can't write 2N in there, but you're saying that these are all 2N. So if that's true, remember, an egg and sperm make a zygote. So let's say somebody else has an egg over here. That egg would also have to be diploid. So 2N plus 2N equals what?
4N.
Yeah. So do you have 4N offspring? Would that organism survive? Let's go back and let's check. I'm going to close these drawings real quick. I'm going to get rid of, or actually I'm going to stop sharing here. I'm going to come back to our karyotype. Here's hero. Are these chromosomes, are there 2 of them for each pair, or are these quadruple? They're not pairs. Are these 4 or 2 for each chromosome?
2.
There's 2. So that can't be true. There's not 4. So let's go back to where we were. Stop share again. I gotta let these little pop-up windows go away. New share. How about that? Nope, that won't work. There we go. All right, so these are going to be sperm, right? These have to be sperm or egg. So I'm going to go ahead and encapsulate these things because they're not showing you the membrane around them. They're not showing you the membrane. So these are going to be sperm or egg. Let's make them egg. I'm going to have a bias towards females. These are eggs. We know in meiosis that we're going, a couple of things here. We go from one parent cell to 4 daughter cells. So here's 4 daughter cells. We go to 4 daughter cells. We also know that we're going from diploid to haploid. I'm supposed to say daughter. This is Mr. Linegar. I swear Mr. Linegar has taken over my body. These are 4 daughter cells. We also know that we're going from diploid parent to haploid daughters. So these are going to have half the information, half of it. So if N, in this case, N equals, what does N equal? How many chromosomes in each one of these cells?
Wait, what was the question again?
How many chromosomes in each one of these cells?
It will be 4.
4. You are correct, sir. You are correct. So now we have, all we have to do is just kind of plug a little information here. So 2n, if 2n equals, if n equals 4, what does 2n equal?
8.
You are correct, sir. So I'm gonna come over here and find 8, and I did, and I'm green. All right, questions, kiddos? Oh, there you guys are. Is it just the 3 of you guys left? That's it? Y'all are the stalwarts. Awesome. Y'all are better than everybody else. There's nobody in the waiting room. We started out more. 8, I thought. Okie doke. Let's see. Clear the drawings. Go to the next problem. Hemophilia. Nice. All right, so let's look at the information that they've given us. So edit the question. So it says, I have hemophilia is rare. It's rare because it's not going to show up very often. If you get it, it usually will cause major problems, especially historically. You bleed like crazy. If you get it, blood does not clot properly. You're going to bleed. If you get injured, I just had surgery. It's one of the questions I had to ask. Do you have hemophilia? I had to answer, excuse me, and I told them, no, I did not. I would have never stopped bleeding if I did. So it's a rare, and it says it's a sex-linked trait. So where do we find sex-linked traits? On the X or Y chromosome?
The X.
TX, I agree. So in this case, this would be a normal female that's heterozygous, and she's a carrier for it. This would be a hemophiliac female. This would also be a homozygous normal female. She is homozygous dominant not to have hemophilia. It's rare, so it's going to be recessive for sure. And then males can be normal. They're going to be X capital H Y, or they're going to be X lowercase y. So the only ones that are in this case that have hemophilia are going to be this one or this one, just like our colorblind example. Color blindness and hemophilia both are X-linked traits. So dudes usually get it before females do, because we only have 2 possibilities. We either have capital H or capital Y. Females have 2 chances of getting the dominant allele. And most of the time, you can see 2 out of 3 times here, they do. They get this dominant allele and they are good. Okay, so let's see. It says predict the phenotypic ratios of the offspring on your calculation using phonics per O. 2 non-hemophiliac parents have a hemophiliac son. So they, in this case, they have a hemophiliac son. I know the dad's genotype is right here because they're non-hemophiliac. So the dad is going to be we'll get his genotype first. So dad does not have hemophilia. Nice. Now let's look at Madre. She's a non-hemophiliac as well. Do we know her genotype? Is it this one or this one? Which one does it have to be? These are our two options. She does not have hemophilia. Which of these two genotypes is she going to be? This one or this one? Is she heterozygous or is she homozygous? That's the question. And I'm not going to answer it. You guys are.
Is she
What's her genotype?
homozygous?
I'm sorry?
Is she homozygous?
Well, let's see. Let's say she's homozygous for it. These are both girls. And these are both dudes. Do any of these people have hemophilia?
No.
Nope. So it can't be that. Can't be that. So let me get my eraser. She cannot be homozygous. Boop. Nice. So she has to be heterozygous. Remember, guys only get their they get the recessive allele, no, excuse me, the recessive allele. They get their X chromosome. That's what, now let's make this a small one. They get the X chromosome from their mother. I know I got my X chromosome from my mother because I can't get an X chromosome from my father. If I do, I'm a girl, but I'm a dude. So I know my dad gave me my Y chromosome, which does not carry hemophilia. It doesn't have it. So if the son has hemophilia, the only way he gets it is from his mother. My mother does not have color blindness, but she did pass down color blindness to me. So then the question becomes, well, what is the phenotypic ratios of the offspring? Now, honestly, how I looked at it, and I did not fault anybody for this. I did not fault anybody for this. There was, I did not. I mean, there were a lot of people that gave me this situation. They said 3, 2, 1. IB said not to give you points for that. Even I did give you points for that because they don't have hemophilia. They don't. There are 3 normal and there's 1 hemophiliac. I did give people credit for it because I didn't show you guys necessarily how to write this. They wanted you to write it this way. Let me clear it. Get rid of my annotation tool. They said that you had to write this specifically. You had to have 2 female, 2 normal females, and 1 normal male, and 1 celiac. Hemophilia. Is that not spelled correctly? Hemophilic, huh? That's funny. Hemophilic. I think it's philiac. There we go. Philiac son. So they wanted the ratio written 2 to 1. Oops. 2 to 1 to 1. These females had the same genotype. This male had a different genotype, and this male had a different genotype. They wanted it 2, 1, 1. And but I felt like if I didn't show you guys that, and if you gave me a 3 to 1, I still counted it correct. And I'm hoping people will go watch these office hour videos. Let me ask you guys a question. Do you think I was too hard on the class today in second and third period? Those kids that are in third period, yay or nay?
No.
Oh my
You-
gosh.
What?
Because like it's so like awkward and frustrating just sitting there. Like when you try to participate and nobody doesn't like at least give an effort back.
So can we spend 2-3 minutes discussing that at the beginning of class? And you think that that social pressure would put, would, if you guys are saying it when we come to class, and it's not coming from me, that the peer pressure, the social pressure would make a difference or not?
It might because like it's coming from a more relatable level, I'm guessing, but I don't know.
I don't know either, but I will tell you this, I'm coming up here with crappy, I'm trying to be very nice and not cuss. I'm coming up here with terrible vision and I'm trying to push through and do the best job I can. And then I sit there and kids aren't doing squat. I want to explode. I don't think it's,
I feel so bad for you because you're
I
doing all
know,
this and
especially because like whenever we'll be answering questions like in class, whenever you ask for like, I don't know, like say we're doing like a worksheet or something, and then you like ask for a question like today with Dylan or like Romello or whatever,
yeah,
and
dude,
they would just like sit there in silence, and it like wastes so much time. And then in
Dude,
the
it wastes-
breakout room, whenever you came in there, and you were like telling us that we don't have to do breakout rooms if nobody's gonna talk. But it's
Yep.
like, I don't know, when it's certain people in breakout rooms, they don't talk until like you say something.
yeah, that's
And it'll just be like one person
BS.
talking.
That's cray. Is it better in other classes or do you think if this is just harder and you have to really think about it?
no, it's like that in every single class, to be honest.
Yeah. If you don't talk to the people that you're in the breakout room with a lot, or like they're not, I don't know, like outgoing enough to just talk no matter who it is, then it's hard.
Yeah, that's gonna drive me crazy. I mean, we have got stuff to do. And the thing is, if y'all don't have this foundation, oh my God, I usually I'm breaking this unit genetics into 2 parts, like giving you guys this first test. The next things that we do for genetics where it gets layered and layered and layered. And I'm telling you guys, for 3 weeks, you're gonna be like, holy crap, this is complicated. This is now getting complicated. And if we don't have people that are, it's just me talking, oh my God, it's going to be hard, like legit. And there's a lot of things that I do in class. Like I've got models that you guys use. Like literally, I got these little models that you guys have to put together using the vocabulary and using the content. And I can't do any of that. I mean, and I know that, and it's legitimately kind of tough. And so like you guys are going to have to learn things without having any kind of hands-on. And without the discussion, that just makes it even harder. Yeah, I don't know what to say. Like, this is going to have to stop now. So we'll spend the first 2 to 3 minutes when we come to class on Wednesday just talking about this and then moving forward, but we cannot stay silent. If so, I'm going to start bouncing a lot more people out of class and they can just watch the videos. Sorry to say it, but if we go to 10, 15 people in class, that's just what we got. And you may as well just watch the video if you're just going to sit there. All right, deuces. I'm gonna leave you guys be.
Wait,
Bye.
Pope.
Thank you.
Whoa, somebody wants. I'll stay back and answer any
Hey,
questions.
I have a
Alright.
question.
Yep, I'll stay. What's up?
So like it's not even like it's not related to the thing, but
Okay.
like okay, say I have a kid, would they be colorblind?
Your child?
Yeah,
I don't mean. Do you have color blindness in your family?
my dad's colorblind.
Your dad is colorblind. All right. So what about anybody on your mom's side? Are you aware of anybody on your mom's side?
I do not think so.
You do not think so. Well, let's just play with it and see.
Oh.
I'm gonna stop sharing. Come back and share again. All right, here we go. So let's see. We've got Tracy Tarleton. That was Tracy that asked that question, right?
Yeah.
This is Tracy's daddy. He's got colorblindness like Mr. Pope. It's funny that is your dad white or black?
He's black.
Probably somewhere, and I hate to say this, but probably somewhere there was an injection of Anglo in there. Probably wasn't consensual.
Yeah. His like
Huh?
granddad is white.
What's that?
His granddad is white.
Oh, his granddad is white. Okay, but it still had to be passed down by a female somewhere.
Mm.
There was something that happened for a female to drop that X chromosome into the mix. Was that consensual or not consensual with his grandfather?
I have no idea. Never met him.
Okay. All right, so this is you. So do you carry that allele? Well, I ain't gonna worry about the guys. I mean, here's the guys, but does it matter? You're not a guy. Do you carry the colorblind allele? Do you carry it? Why
Oh,
or no? Are you a carrier for colorblindness? What do you think, kid? This is the genotype for normal. This is normal, normal vision, normal.
oh, then no.
Hold on, this is normal. Let's look at a carrier, a female that's a carrier. A carrier female for colorblindness. That's supposed to be a C. That's terrible. Let me change that. There we go. So one dominant allele, one recessive allele, and then this is a color blind female. Two recessive alleles. So which are you? This is you. Are you this one, or this one?
No, I don't think so. Cause there's like 2 recessives, but it's heterozygous, so it's
Yeah,
not
you're
recessive.
heterozygous. So you're heterozygous. So do you carry it or not?
Oh, never mind. I do.
You do. Do you see this? What I'm drawing?
Yeah,
Yeah, that's you.
I see
So
it.
yeah, you do carry it. You have it. So there's when you mate one day, you're gonna mate with somebody. I'm assuming. Yeah, unless you're a virgin your whole life, which is unlikely. You'll probably get married and have a child. So when you do, this being you here, if your husband, if you guys get together, you'll have the probability that your daughter is colorblind is 0. This is a little bitty C. That's a big C. This is a little C right here. But the probability that you have a son that is colorblind is 50% if it's a male. The probability of having a colorblind male is 25. That's right there. But if it's a male, it's 50%. Does that make sense? You know what I'm saying? Like you got a 1 in 4 chance of having a male colorblind son, but if you have a son, he has a 50% chance of being colorblind. Now
Yeah.
if we're talking about just a son, it's only these 2. Yep. So is it possible that you have a colorblind child? Yes. And it's really cool to be colorblind. I can speak from experience living this way my whole life. I have the
hard?
ability. No, it's well, I mean, there's some things that are challenges, right? Like I don't do color that coordination in terms of clothing very well, but I don't really care anything about fashion anyway. I don't really care, no big deal. But camouflage does not work very well. Color-based camouflage does not work well with me. Like I say that, I mean, it doesn't work well, but it's great for me because I can see right through their mimicry. They're trying to mimic a plant, and I go, that didn't work for me. It's pattern. I am super keyed in on pattern, and I can notice changes in patterns better than a normal vision person. Normal vision people or using color to try to find their way through a camouflage environment to see organisms like a rabbit hiding in the grass. They stand out a little more so because I'm not so much looking for distinguishing their color as much as I'm just looking for a break in the pattern in the grass. And they can't mimic grass perfectly in pattern. They can mimic the color itself, but they can't mimic the pattern perfectly. Because grass is going to fold over and make all sorts of shapes, right? So I can see through it pretty well. It's great, and I'm a hunter, so it's easy. I thought, oh, there's something. Oh, there's something. It's easy.
Have you ever tried colorblind glasses?
I have tried them once with at a neighbor's house. To me, I didn't think it was that big of a deal. I think I've seen the advertisements where the kid. Have you seen the one where the kid cries? He's spits along. Goes, oh my God, I see color. Boo. I think that's just all marketing. I mean, they do make glasses that make it easier, but I don't think it's like, oh my gosh, this is so grand. Oh my gosh, it's not that big of a deal. And I was a merchant marine. I was a sailor and I used to sail all over the place, right? And we would be out to sea. And when you come into port, you're using red and green buoys to make sure that you're in the channel. Because if you're in a boat and you're getting in shallow water, our boats, the underneath, you see the boat on top of the water, but you don't realize how much of the boat is actually underneath the waves, underneath the water. And when you're coming into a port, you can't go in too shallow water because you'll run aground, you'll wreck. This is why some of these ships wrecked. When they were coming and exploring the world, they would run aground and hit reefs and hit shoals, hit things. And so the United States has great ports compared to other places in the world. Believe me, it's awful going into foreign ports, if it's a developing country anyway. But we've got these system of red and green buoys that tell you where you're supposed to be. I can't distinguish the color. I just would see that there's two buoys and I know I need to stay right between them. And I don't remember if on the left is red and on the right is green. I don't remember. There is a pattern to it. I don't remember what the rule is. I just knew that I had to stay between those two buoys and be very careful about it. So I was always on my tippy toes coming into ports. Okay, doke, kids. I'm gonna leave you guys be unless y'all have any more questions.
No, thank you.
All right.
Bye.
You guys go play in the street.